Today I will explain the introduction of this assignment. So, one of the most important aspects of electrical engineering that guarantee the effective and secure operation of electrical system is developing a balanced load on distribution board design. In a three-phase system, proper load balancing means dividing electrical loads equally among the phases to avoid overloading any one of them. This procedure is necessary to keep the system stable, improve energy efficiency, and increase the lifespan of electrical parts. For the problem statement that we can tell, such as load imbalance are a typical problem in many electrical distribution systems that can cause a number of issues. So, uneven voltage drop brought on by an unbalanced load lead to inefficient energy distribution and increases operating expenses. Additionally, it may result in equipment wear and tear, conductor overheating, and an increased danger of electrical fires. Furthermore, harmonic and other problems with power quality brought on by load imbalance can harm delicate electronic equipment. Resolving this imbalance is essential to maintain the electrical system dependability and security. The objective of this assignment, the project main goal is to create a balanced load distribution board that distribute electrical loads over all phases that efficiently as possible. The initiatives seeks to, such as firstly, um, reduce the amount of voltage loss between phases. Then, secondly, boost the electrical system overall effectiveness. Then, thirdly, extend the life of dependability of electrical parts. Then, number four, prevent needless losses to cut down on energy expenses. Then, lastly, we can verify adherence to safety and legal requirements.
Hi, my name is Uday Kumar Satisilan, metric number 211090989. So today I will be presenting about the lighting design for this project.
Okay, now let's discuss about why lighting design is really important while designing a building. Okay, first of all, there are four prominent points that has to be highlighted. First comes the visibility, second is safety and security, third is health and well-being, followed by the productivity. Okay, so these are the four most prominent aspects that has to be considered when designing a lighting for a building. Okay, so the visibility provides adequate amount of illumination, which is also interrelated with other points for safety movement, also the enhance the productivity and also well-being of their employees and the person. Okay, this is the three most important parts considered for the illumination in a room. There are three, namely visual performance, visual comfort, and also visual environment. Next, now let's talk about how lighting design is performed. First of all, it begins with obtaining and analyzing the building layout. Second, it goes with calculating the dimension of each room. Okay, when it comes to dimension, we have to calculate by three: length of the room, width of the room, and also the height of the ceiling, or the ceiling height of mounting. Okay, so third, we have to calculate the room index for each of it. So how do we perform it? By using this formula, which is shown in the screen. Next, we look out for the suitable lamps and casing which are JKR certified. So I have displayed here the sample of lamps that we have used in this assignment, and each of it is JKR certified. Okay, this is the sample of data sheet that we have obtained for the specific type of lamp. Okay, here they have mentioned the dimension, the coefficient of the lumen for each lamp. Okay, next we have to obtain the coefficient of utilization followed by the average luminance, lux, and also lumen for each lamp. Okay, what is coefficient of utilization? It's a factor used to determine the efficiency of a lighting fixture in delivering light for a specific application. Next, so why and what are the factors that are being affected by the coefficient of utilization? There are four. One is efficient of luminary, next followed by luminary distribution, geometry of the space, and also the reflectance of each room. Okay, this is sample of tabulation of data that we did for each room respective to its length and dimension, followed by its luminance, COU, and so on. Okay, next, for this project, we have standardized the maintenance factor of 0.8. Next, we calculate the number of lumen suitable for per room as per this formula. Okay, it's used according to this formula, n equal to EAV times length times width per LDL times COU times mm. Okay, even though we all know that calculation could give us a roughly defined of number of values of lamp, but in reality, it might differ according to the preference. In this case, the actual number of lamps might exceed the number of calculated lamps. And this is the example of layout. How did we lay the lamps in the room? So that's from me. Thank you.
Okay, now I will explain for the socket design. Okay, the socket design is crucial across various fields, including mechanical, electrical, network engineering, and medical applications due to its significance, impact on functionality, safety, and user experience. In electrical and electronic engineering, it ensures reliable connection and signal integrity while increasing the durability of connection. Consideration in socket design include material selection, ergonomy, thermal, and electrical conductivity standardization, and compliance with safety regulation. Overall, good socket design practice practice are fundamental in ensuring reliability, efficiency, and user satisfaction across application. For the type of the socket, so we have used three socket. So firstly, we have used 300 mm 13A switch socket outlet. Then secondly, we have used 800 mm 13A switch socket outlet. Then lastly, we use 1450 mm 13A switch socket outlet. Okay, now the type of load that we have used for this drawing, we have used the single socket outlet, double socket outlet, then the ring socket outlet. Okay, now I will explain the selection of the socket. The selection of the socket made by us depends on the area of the place. So, we refer to the table that has been prepared as follow. If the place has an area 20 millimeter square, so we will choose the single socket and double socket. But if the area of the place is between 100 millimeter square, so we choose the socket ring. The selection of this socket also depends on the rule that's set by the JKR. Then the socket has been placed in this modes can be used by the community if they want to install a fan, install a computer, charge a phone, and so on. So every socket places can be used for various facilities in the malls.
Hi, now I will explain about aircon design. For our assignment 2, in aircon design, we use split unit type of aircon as requested in assignment number 2 for both building malls office. So why it is important to do aircon design? This is the first one is to enhance comfort, ensure consistent temperature, adequate ventilation and optimal humidity level. As we know, our aircon we can set temperature, for example, like 25 degrees Celsius. So it will constantly give a 25 degrees Celsius temperature to create environment that promote comfort and well-being, leading to increased productivity and satisfaction among occupants. For example, like in our office, people used to work in it, so we need to supply with a cool air in order there to have a comfortable working space. It also will increase their productivity in doing work. Next one is well-designed aircon system not only benefit environment by reducing carbon. For next part, we use formula to determine horsepower aircon for a space. So there is formula provided in slide. You can see that horsepower aircon equal to area in feet times with 60 or 70 is cooling factor divided by 9000. Or for cooling factor, we can choose either 60 or 70 depending on room. For example, if room is more packed, we can use 17, or less we can use 16. For we can see the example here, a room have an area which 233.58 feet square times with 70. We consider that the room is a meeting room, so meeting room is more packed. So divided with 9000, and we get 1.5 horsepower required to cool the area. So thus, aircon can be installed either we use two method, which is use 2 unit of 1 horsepower aircon, or other we use 1 unit of 1.5 horsepower aircon. But for our design, we consider to use 2 unit of 1 horsepower aircon because it can give more equal distributed air cooling inside the area. After determining the horsepower aircon, we go for aircon selection. So nowadays there is two type of aircon popular, which is inverter type and non-inverter type. So we do the comparison to determine which one is better to be used for our design. So in inverter type of aircon, it have variable speed compressor, which is it can speed up or speed down depending on temperature. While for non-inverter type, it have fixed or single speed compressor, which is you need to control it manually either to speed up or speed down. Next, for inverter type of aircon, it will save the operating cost in the long term, while for non-inverter, it higher operating cost in the long term. However, for inverter type, it had higher cost compared to the non-inverter, which is low cost. For inverter type, it provides with more efficiency and use less energy, while for non-inverter is less efficient and use more energy. And lastly, inverter type is more quieter operation compared to non-inverter type. It has noisier operating. So for our design for boss building, we consider to use inverter type of aircon because it fulfill our requirement and our selected design. And also it have quieter operating. So this is good for office and mouse. Okay, for the next part of aircon selection, actually there is many type of aircon we can see at the marketplace right now, but I will state 3 in our slide, which is wall type, ceiling type, and cassette type. For our design in office, we mainly use wall type aircon. For in our mouse and ruang solat utama, we use ceiling type of aircon because ceiling type of aircon will provide better distribution of cooling air in large area.
Okay, good day and salam sejahtera doctor. My name is Lee Yisheng and I'll be doing the explanation for the load calculation and load balancing for this presentation video. So what is load calculation? Load calculation is where we have to calculate every load for every single electrical appliances that was used in this installation project. So in load calculation, we have 3 different parameters that has to be considered: the total connected load, diversity factor, and the maximum demand. So first, I would like to explain about the total connected load. So the total connected load is the total electric power consuming rating of all devices, the maximum load of equipment and appliances at a particular time over a span of time. So example, so if we have a fluorescent batten that is rated as 14 watts and we have, let's say, 100 of them in a single building, the total connected load will be 14 watts times 100 of these fluorescent battens. So in total, the total connected load will be 1400 watts. Okay, next, I'd like to talk about the diversity factor. So the diversity factor is defined as the ratio of the sum of the maximum demands of various parts of a system to the coincident maximum demand of the whole system. So This is the table for the diversity factor. So, for the lighting system, the diversity factor for office buildings are set but at 0.8 and the MOS will be set at 0.9 according to JKR. The same goes for ceiling fan. The diversity factor for office buildings is 0.8 and for MOS it is 0.9. For air conditioning units, the diversity factor is 1.0 and for sockets the diversity factor is 0.4. The next factor is maximum demand. The maximum demand refers to the highest amount of electrical power consumed by a facility, system or circuit with a specified period. It represents the peak load or demand that the electrical system must be able to handle. To calculate the maximum demand, we just take the total connected load multiplied with the diversity factor. Next, I'll be talking about the load balancing of the system. So, why is it important to balance the load? The first reason being efficiency. By balancing the load, we can prevent power loss from happening. The second reason is to prevent current from flowing backwards. An unbalanced load will cause a voltage difference between loads, so there's a likely chance of current flowing in through the different phases. So the third reason is being voltage stability. By balancing the load, there will be less chance for the voltage to fluctuate. So the last reason being protection of the circuit or the equipments. So equipments will be damaged due to exposure to imbalanced current or voltage levels. So it is best if we can balance the load. So now I'm going to be talking about how to balance the load. So the first step is to insert the load into their respective phases. The next step is to ensure the load doesn't pass the limit for each way. For light bulbs and ceiling, there can only be a maximum of 10 of those electrical appliances in a single way. For air conditioning units, there can only be one of those in a single way. For sockets, there also should not be more than 10 per way. So the third step is to calculate the rated current for each way. So to calculate the rated current, we take the maximum demand divided by the voltage, which is 230 volts, divided by the power factor, which we assume is 0.85. So next, I'll be explaining about the MCB selection and the cable selection for this project. According to JKR, the MCB rating for lamps and ceiling fans should be 6 amps. For air conditioning unit, the MCB rating should be 32 amps. For socket, if it's a 1-gang socket, the MCB rating should be 16 amps. If it's a 2-gang socket, the MCB rating should be 20 amps. If it's a ring socket, the MCB rating should be 32 amps. Okay, so right now I'm going to be talking about the wire selection for this project. So according to JKR, the wire size for lamps should be 1.5 mm square. The same goes for ceiling fans, which is also 1.5 mm square. For air conditioning units, the wire size should be 4 mm square. And for sockets, no matter 1-gang, 2-gang or its ring size, the wire size should be 2.5 mm.
Salam Sejahtera and a very good day to Dr. Zaidi. I will be presenting about the economic decisions we took in our system design. Firstly, for the lighting, we decided to choose Good Light lighting, mainly because it is approved by JKR standards and Good Light offers quality lighting products at a cheaper price, as it is a local brand compared to buying foreign product. Our group went for fluorescent T5 lighting because it has good lumen output capabilities compared to other traditional lighting such as incandescent lamps. The upfront cost per light bulb is also cheaper compared to LED lighting. Fluorescent T5 lighting has an average lifespan of 8,000 hours and is much more efficient compared to fluorescent T8 and incandescent lamps. To save costs when it comes to the designing of our lighting, we determined the right quantity of lighting to be used to efficiently light out an area using the room index and lumen method of calculation. We also used the SHR max method of calculation to determine the uniformity of illuminance in an area. This will help prevent wasting extra money on unnecessary excess lighting. For the socket brand, we decided to go for Schneider Electric because it uses high-quality imported Bayer PC material from Germany. The switch socket outlet also has high heat resistance to prevent its colors from fading. Together with its glossy texture, it is more durable and more reliable. To save costs in the socket design, we decided to use a ring circuit at whichever place is suitable. because it is much more cost effective than designing multiple single switch socket outlets. We also try to keep the maximum number of sockets per area to be less than or equal to 10, as it is the maximum number of sockets that can be configured in a ring circuit according to JKR standards. For the air conditioner brand, we decided to use Panasonic air conditioning because of its cutting-edge technology that prioritizes energy efficiency. We choose a premium model, Panasonic X Premium Inverter XU series, as it has inverter technology and has a 5-star MEPS rating, which uses 52% less energy compared to 2-star rated air conditioners. Hence, more energy can be saved in the long run, and as a result, more money can be saved from using energy-efficient air conditioners. Lower MEPS rated air conditioners have higher inductive loads as their motors run less efficiently, which may lead to a significant power factor drop. This will cause a power factor surcharge penalty every month if the problem is not solved. As for the air conditioner design, we determine the right quantity of air conditioners to cool down the temperature inside each room using the formula air conditioner horsepower equals to the area in feet multiplied by the cooling factor and divided by 9,000. This is to prevent wasting money on unnecessary excess air conditioners, which may lead to more electricity consumption and higher monthly electricity bills. The JKR standard also only allows one air conditioner type load per circuit. As we can observe from these three figures, we can see that choosing an inverter technology air conditioner has a significant impact on the economic decision to our design. It can be estimated that 98 ringgit can be saved per year for 1 horsepower air conditioners, and 127 ringgit can be saved per year for 1.5 horsepower air conditioners, and up to 309 ringgit can be saved up per year for 2.5 horsepower air conditioners. That is a total of 1,960 ringgit, 2,530 ringgit, and 6,166 ringgit respectively for 20 years for an average lifespan of an air conditioner. For the electricity bill estimation, the office building ground floor comes up to 17,238 ringgit and 72 cents per month. The office building first floor comes up to 19,829 ringgit and 89 cents per month, and the malls comes up to 7,463 ringgit and 75 cents per month. That is a total of 44,532 ringgit and 36 cents per month for our overall design. Next is the impact of our design towards society and the environment. For our lighting design, the lighting we chose also take into account the suitable color temperature for each type of room. For example, the office restrooms and the malls, we chose a warm white temperature around 2500 kelvins to 3500 kelvins to produce a much more soft, warm and inviting effect. While for the office workspace, we went ahead for a neutral white or cool white around 4000 to 5000 kelvins for a neat, clean and efficient effect. It is to ensure that the illumination is intended to reduce eye strain and tiredness. If the light is too glaring or too bright, it can cause discomfort and headaches. The public safety is also taken into account the lighting design, such as emergency lighting and color signs are installed in every room of the office and malls at strategical positions. This is to ensure that the safety of the people by providing safe evacuation routes in case of an emergency. The lighting we chose also has an effect towards the environment and sustainability. T5 fluorescent lighting is more energy efficient than incandescent lighting. However, it also contains small amounts of mercury which can be toxic towards the environment and human health. Improper disposal of mercury can lead to the mercury leaching into the soil and waterways, which can cause soil contamination and water pollution. Therefore, it is important to have proper waste management and recycle process for fluorescent lamps. The socket design also plays an important role on society. The socket design takes into account the mounting height of the socket, whether 300mm, 800mm, or 1450mm from the ground to make it easier to access and comfortable for the user to use. The socket design also plays an important role in safety. As a safety measure, sockets are placed far away from water sources to avoid any electrocution accidents. Our socket design also plays an important impact towards the environment. We chose Schneider Electric because of their compliance with the latest regulations and their transparency on environmental impacts. The materials and manufacturing process of their products are certified to be low carbon footprint, and their materials are also certified to be free of SVHC substances, toxic metal free, and mercury free. The AC design also incorporates public health for the society. The Panasonic AC model we chose has NanoX technology, which uses hydroxyl radicals to effectively inhibit airborne pollutants, dust particles, as well as 99% of bacteria and viruses to ensure that the indoor unit is always dry, clean, and fresh. This is to provide a cleaner environment and prevent its users from falling sick to airborne diseases caused by bacteria and viruses suspended in the air. It also protects people with allergies to dust and pollen, and also people with chronic respiratory diseases such as asthma. The decision behind our AC design also takes into account the impact towards the environment. The Panasonic AC model we chose uses R32 refrigerant instead of R410A. The refrigerants are one of the biggest contributors to global warming and depletion of the Earth's ozone layer. R32 is the latest and best refrigerant currently available in the market, with the lowest global warming potential GWP of 675 and the lowest ozone depletion potential ODP of 0. The Panasonic AC model we chose also features inverter technology. Inverter technology is generally more energy efficient and produces lesser noise as they are quieter compared to non-inverter ACs. This will reduce noise pollution in the environment and ensure public health as noise can cause discomfort and headaches. Our decision behind our load design and distribution board design also takes into account impact towards the society. The decision to develop a balanced load for all DB design. We also practice to separate the DB for lighting, power, and AC as it is proper practice according to JKR standards for precaution and safety purposes. It reduces the risk of overloading any single DB, which can prevent circuit breakers from constantly tripping. The DBs are isolated for each part of the building: office ground floor, the office first floor, and MOS as specific rooms such as the billiard switch and the billiard M at speed for easier maintenance and troubleshooting purposes. The load balancing also fulfills the criteria that the percentage difference of rated currents between one and another phase of the three-phase system does not exceed 10%. The selection process for the correct MCB rating and cable size must follow JKR standard and IET regulations. For example, the MCB rating for lighting and fans is 6 amperes, for the socket with ring circuit design is 32 amperes, and ACs are also 32 amperes. The cable sizing for lighting and fan is 1.5 millimeters. For sockets, it is 2.5 millimeters, and for AC, it is 4 millimeters. Thank you.
And so, in conclusion, effective lighting design, socket design, air conditioning design, and load balancing are very crucial components in creating functional, efficient, and comfortable living and working environment. This design aspect require multiple approach, for example like calculation, consideration that combine electrical and interior design. Prioritizing many aspects during the design and planning stage result in surrounding that visually appealing, comfortable, safe, efficient, and sustainable. Okay, that's all from our group. Thank you.